Hey everybody, 4.3 isosceles and equilateral triangles coming your way. Our objective today is going to be using properties of isosceles and equilateral triangles. Vocab words, and here they are. Legs, base, base angles. Write them down. Alright, so the legs. The legs are the congruent sides of an isosceles triangle. So again, if we look at an isosceles triangle, they are those two congruent sides, those two sides with the red tick marks. But the base is the non-congruent side in an isosceles triangle, so our base would be this bottom side. Legs would be the top two right here and here. And then our base angles are the two angles at the base of the triangle. So our base angles, we have our base angles would be at the very bottom. Yep. We have legs, base angles. Moving on. An isosceles triangle, looking at this, 3 is going to be known as our vertex angle. So where those two congruent sides come to a point, when those two congruent sides come to a point, that is known as our vertex angle. So angle 3, where the two congruent sides go to a point, that is our vertex angle. The other two angles are known as our base angle. We talked about that with base angles. Sweet. Okay, two theorems I want you to know is the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite of the sides are congruent. Okay, conversely, if you look at an isosceles triangle, exact opposite, if two angles of a triangle are congruent, then the sides opposite of those angles are congruent. So if you look at both of these opposite sides, C would be congruent to angle B because they're opposite sides of AB and AC. And looking at that second one, the converse, if we know that angle E is congruent to angle F, we know that DF is congruent to ED. Sweet. Okay, so here we are looking for the measure of angle F. So we know 1 degree is 22 degrees. How can we figure out D and F? I want you to brainstorm an idea, see if you can come up with it. Alright, we know E. We don't know D, we don't know F. So when we look at this, we have 22 degrees. It's the only measurement that we know of. However, we also know that both ED and EF are congruent. If ED and EF are congruent, that tells me it's an isosceles triangle, which means if they are congruent, D and F have to be congruent to each other based on our theorem. Alright, so now what we do is we take 180 and we're going to subtract 22. When we subtract 22, we get 10, 7, and your answer is going to be 158 degrees. Now, what does that tell us? Well, that tells us that both of those angles, D and F, add up to equal 158 degrees. We also know that D and F are both half of 158 degrees. How do we know that? It's because those are our two missing angles and they are equal to each other. They are exact half of 158. So if you take 158 and divide by 2, what do you get? You get a measure of 79 degrees. 79 degrees for F, 79 degrees for D. So what's the measure of angle F? 79 degrees. Awesome. Let's try another one. Okay, find the measure of angle G. Now we know that the measure of angle G is x plus 44. We know that the measure of angle J is 3x. How do we figure this out? Set up an equation, think to yourself, set up to an equation, and solve. See what you get. Alright, we know that angle J and angle G, they have to be equal to each other. How do I know that they are equal? Well, it's an isosceles triangle, which means if those two sides are congruent, that means angle G and angle J are congruent to each other. So x plus 44 is equal to 3x. All right, so now we have x plus 44 is equal to 3x. We get our x's next to each other. Or sorry, combine our x's. And you get 44 is equal to 2x. Divide each side by 2 to get x all by itself of 22. Now the question is, are we done? The answer is no. We found x. We haven't found g yet. So take that 22, and what do we do with it? Plug it back in. We plug it back in to get 22 plus 44, and our answer is going to be 66 degrees. Awesome. So come up with that. We're able to set it equal to each other because of our theorems that we know. We know it's an isosceles triangle, so we can set them equal to each other. Once we set them equal to each other, it comes down to algebra, and we know our algebra. Okay, here's two corollaries that go along with it, an equilateral triangle. If a triangle is equilateral, then it is equiangular. If a triangle is equiangular, then it is equilateral. Give this one a write down in your notes. Write them down, line them up, write them down. All right, let's try a couple examples. First one, find the value of x. Okay, it tells me that KL is equal to LM and equal to KM. How do we know that? Because of our wonderful tick marks here. Okay, we have all of those. We have that information. So we know that. What type of triangle is this? Equilateral. Because we know it's an equilateral triangle, we also know what? Equiangular. Okay, now we're starting to build on what we know. Now that we know it's equiangular, what measures each angle? 60 degrees. Well, 60 degrees, and 60 degrees. So we know that angle L has to be equal to 60 degrees. We also know that angle L is 2x plus 32. If we set that up into an equation, we can solve for x. Okay, and again it comes down to our algebra. Subtract 32 from each side. You get 2x is equal to divide by 2. X is equal to 14. Awesome. Bingo, bango, bongo. Sweet. Last one. Find the value of y. Now, we know angle O, angle N, angle P are all congruent to each other. What does that tell me? Well, that tells me that each angle measure is 60 degrees. Okay, again, we know 60 degrees. Now, we have two equations here. That's not 60, that looks like 600. That is a degree symbol. We have two side lengths here, which really have nothing to do with the 60-degree angles, right? Remember, all of those angles being 60 degrees doesn't just tell me that it's equiangular, it also says it's equilateral. So if it's also equilateral, we know two sides, we have two expressions for each side, set it up as an equation, which is 5y minus 6 is equal to 4y plus 12. I'm going to put my numbers with numbers, letters with letters. Add 6, add 6. 5y is equal to 4y plus 18. Subtract 4y on each side because I want my letters together. Y is equal to 18. Awesome. And we are done. Okay, that's the last note of 4.3, isosceles and equilateral triangles. I hope you enjoyed it as much as I did. I love doing this. Okay, we'll see you tomorrow. I'll hand you the homework.